Okay, I don't know about you, but when I woke up this morning, I had a question in my mind that needed answering, and that is, why don't trees leave giant holes in the ground? I had a need for knowledge, and I think I found it. So with that in mind, let's play this video and see what on earth it talks about. Okay, let's go.
And largest living things on Earth, with the most massive.
I swear to God, I had so many your mum jokes into my head at once. That was crazy. Okay, but we're gonna keep it PG, all right? Because I want kids to be able to watch this. Trees are the biggest thing on Earth. Well, have you seen your mum? I don't think you have.
Tree weighing almost 2,000 tons, as much as 10 blue whales. But instead of floating weightlessly in the ocean, it reaches 25 stories into the sky, held in place by surprisingly shallow roots.
I mean, trees can float. I mean, you know, let's be very clear. I mean, wood for centuries was the primary material used to build a little thing called boats. It's just, yeah, it's just wood is incredibly, it's not very dense for its size, which is why it floats. But yeah, okay.
Think trees grow from the ground because, well, they're made of stuff and there's stuff in the ground. But if something so massive and huge ate something down below...
Oh, I see where it's going. Right. It's asking the question, like, you know, if trees eat the dirt, then why don't they basically dig themselves a hole? Well, the short answer for that is they don't eat dirt. What they consume is CO2, carbon dioxide, water to aid the chemical process, and then with sunlight, they have photosynthesis to generate basic sugars. And then it's those sugars they use to kind of, you know, grow cells and heal and repair and what have you. That's how it works. They don't literally eat dirt. They just, you know, they use it to extract certain minerals and fluids, but that's about it. But okay.
It would have to leave holes. Instead, trees are growing by literally eating thin air.
Yeah, they breathe. Yeah, they breathe.
But this is only half of the story, because down in the ground...
Oh shit, it's only half the story?
Roots are mining rocks in ways weirder than you can imagine. How does this work?
I can imagine some pretty weird way to mine things.
How to eat air to grow huge. Carbon is the most valuable material for living things. A chemical multi-tool you can make almost everything from, and a good amount of it just floats around in the air and the oceans. What makes plants so incredibly successful is that over 1 billion years ago, their ancestors became better than any other living thing at harvest.
Chloroplasts. I think it's the part of the cell that processes sunlight and CO2. So it's the part that makes the sugars. I could be completely wrong there, but I'm pretty sure from my high school biology, that's where we learned it from.
Carbon. They used it to grow and grow and grow. Today, plants make up 80% of the biomass on Earth and are the basis for all complex life. All animals eat either.
I mean, photosynthesis is incredibly inefficient, though it should be said. It's just the fact that because sunlight and because carbon dioxide is like readily available, you can be inefficient with it. You don't, unlike an animal which has to hunt, like a predator that has to hunt something, where it has to have a much more efficient digestive system to get as much nutrients out as it possibly can. You know, sort of think of like a reptile or something like that. Plants can be very inefficient at extracting sugars because, you know, it's abundant and they've got nothing but time. So
plants or animals that eat plants to get the carbon they need. Trees are an especially ingenious way plants found to harvest massive amounts of carbon. Trees are big and heavy, so they need a lot of material. But the atmosphere is only about
not as big and as heavy as your mama. Okay, stop it now.
0.04% CO2, 425 CO2 molecules per million molecules in the air. To get a single ton of carbon, a tree has to process 6,000 tons or...
Okay, whoa, that is crazy. I had no idea about that. So for every ton of carbon, it has to basically siphon through 6,000 tons of air. Like, imagine a situation where, like, in order to get, like, I don't know, you're eating something, right? And you need a certain thing to survive. And you basically have to sieve through 6,000 of X in order to get one of Y. So the Y is the thing you need, and you have to go through 6,000 times that volume in order to get one of that thing. That's wild. That is crazy. I had no idea.
5 million cubic meters of air. This is a lot. So trees developed sophisticated biological...
They're basically built to just like funnel air through them and just extract as much CO2 as they possibly can.
Industrial megalopolises. Their crowns.
Sorry, what? Megalopolises? Megalopolises. Okay.
A huge industrial park network made from dozens of branches, sub-branches, and hundreds of thousands of twigs that can sense the sun and shape the tree to grow towards it in slow motion. They're carrying up to 1 million leaves, the industrial parks where a tree eats and builds, consuming extreme amounts of resources from the air and fed by the roots down below while vomiting waste and...
Oh, okay, I get it now. So basically, it's the leaf itself is the thing that does all the work. Like the trunk and the branches are just like the infrastructure that keep everything kind of stitched together. But the leaves are the actual factory floor. That's where the light gets, that's where the CO2, the water, and the light mix to generate sugars that then get pumped back into the core of the tree and then sent out to the places where it's needed. I'm with you now.
Changing the climate around them. Let's zoom into a single leaf. It's made from hundreds of millions of factory cells and optimized to have as much surface area and be as thin as possible to harvest sunlight. While your skin is hundreds of cells thick, a leaf can be just 10 cells top to bottom. On their top, leaves have only a single ultra-thin layer of protective transparent skin cells that let light through and keep water in.
Yeah, I remember this from my biology class. It's like a waxy substance that's on the top that keeps them water resistant. But it allows, and then that's on the top. The bottom of the leaf, obviously, because the top of the leaf is where the rain hits. The bottom, it doesn't much, and so the bottom of the leaf can be quite soft, and often it has little hairs there, and it's them which allow the flow of air to go through. By the way, the flow of air to go through, and then that's where the process all happens and mixes up.
Below them are layers of factory cells, filled to the brink with chloroplasts that do the actual work.
Yeah.
Beneath them, a spongy layer of loose cells enables gases to travel around.
There you go. Yes, I was right.
The whole leaf is traversed by a network of vein-like superhighways that carry sugars back down and bring water and minerals up from the roots.
I was right. Yay!
At the bottom is another protective layer of cells interrupted by hundreds of thousands of stomata, tiny mouths opened and closed by 2 guard cells that look a bit like lips. Each day, an adult tree pulls up dozens of liters of water all the way from its roots in the ground to these veins, where about 95% of it is sweated out through hundreds of billions of these tiny mouths. This cools the leaf factories, which need to stay in direct sunlight as long as possible, and the air around the tree.
That makes sense too. I never thought of it that way before, but it's like, yeah, it's like, if your job is to basically stay in direct sunlight as long as you possibly can all the time, then you're going to need some form of cooling. And I guess that's it. It's the same way that, you know, the way we cool down is we sweat, and then as the water evaporates, it takes heat away from the body. Likewise here, a lot of the water that gets pumped up, some of it's used for chemical processes, but some of it's also used to evaporate in order to keep the cells cool so that it can stay, don't overheat and can still function. That's interesting. Okay.
And
we're learning new things.
Surrounds the tree with an invisible mist. The vapor from a forest of billions of trees can seed clouds and create rain. Rainforest is literal. Without the trees, the Amazon would be a sad, dry shrubland or desert. The other 5%...
Well, you just said Africa. The African plains used to be a rainforest at one point. And yeah, when they all disappeared, you just got left with that. Because if you think about where it is, it's all on the equator. So there's no particular reason why. So all the trees work to suck all the moisture out from the ground. And then it goes, and then that gets floated up. That evaporates up into the air, sort of taking away the heat. But it rains back down. So they basically kind of work to maintain and trap moisture where it is. Hence the reason rainforest. But if you remove that, then there's no more cycling of the water, and so things just dry out and die. That makes sense now. Okay, I did not know that. I'm learning stuff.
The water is used to keep the cells alive and to power the factories where the magic happens, photosynthesis. We're not going to explain the details here, but in a nutshell, with the energy from the sun, water molecules are split into hydrogen and oxygen. The oxygen is ejected while the leftover hydrogen and CO2 are forged and reduced into glucose, a simple sugar that's both battery and building block, and the source of most carbon in the world for most animals. Oxygen is not just garbage to the tree though. To actually use the energy stored in the glucose, the tree has to burn the sugar, just like we humans do, with cellular respiration. So all living cells in the tree suck in oxygen through the tiny leaf mouths, cracks in the bark, and even root tips tapping into tiny air pockets hidden in the soil. This respiration runs non-stop.
That's so interesting. So it's every single part of the tree. So I was the food processing is in the leaves, but the air processing, the flow of the water and gases is through the entire tree. That is interesting. I didn't know that part.
And especially at night when the leaf factories stop production. Trees actually reabsorb some of the oxygen they produce, and almost all of the rest gets used up by microbes and everything else breathing nearby. Most of the world's free oxygen doesn't come from trees, but from algae and cyanobacteria in the oceans. But this is only half of the story, because the even more insane parts of trees...
I'm pretty sure that it's the algae are like the more efficient when it comes to gases, converting the gases or breaking down gases from CO2 to oxygen. I'm pretty sure they did an experiment years ago where they did something to encourage more an algae bloom in the ocean, and then they realized that within the algae bloom had within a few days, I think sucked the equivalent of like a week's worth of coal power plant or some shit like that, something like that anyway.
Are the second invisible crown, the underground empire of the roots. Most of the water a tree needs comes from rainfall, which soaks mainly...
That's what incels call their bedrooms, the underground empires.
...into the upper layers of soil. Annoyingly for trees, their crowns are big umbrellas, so their roots need to spread out far and wide towards the side. About 50% of their roots are packed into the top 25 centimeters of soil. They're not a mirror image of the crown, but a dense, tangled mat deeply intermingled with their neighbors. Only if it's very dry do roots grow straight down to tap hidden water reserves, in extreme cases more than 20 stories deep. But
I had no idea they go down that far. I mean, it makes sense. I mean, if you're in fucking the middle of the Sahara, and the only water you've got is half a kilometer down, then what else are you gonna do? But that's impressive. I did not know that. I didn't realize it could go that deep. That's kind of wild when you think about it.
this is a rare exception. Most roots reach down 7 meters. But roots have a far more complex job than just catching water. Just like you can't build a city from only bricks and steel, trees also need some rare materials. Phosphorus to build DNA, nitrogen for proteins, and many more. And all of these are stealthily buried underground. Rocks, dry patches, nutrients, and rival roots are all scattered unpredictably and chaotically. To navigate this shifting maze, roots evolved a specialized sensor at their very tip, the root cap. Each cap is filled with gravity-sensing cells, in which tiny dense particles sink like pebbles.
So, human beings aren't the only things that can sense things in their tip, huh? Is that what we're learning here? Okay.
Settling in a jar of water, so the root always knows which way is down. As it pushes forward, specialized cells detect moisture, temperature, chemical gradients, and the smallest vibrations from water. This raw data flows into the root's command center just behind the tip, where cells produce electrical pulses and move transmitter chemicals around. Signals from the soil are processed, interpreted.
I'm guessing what it basically means is there's a certain, as it responds to stimuli, the growth, how it grows is like the direction is kind of, so basically if it needs to go that way, more growth takes place over here, which pushes it that way. If it needs to go that way, more growth happens here, which pushes it that way. And then doing that, it's kind of always moving towards the thing it has to move towards. I think that's how it works. I think.
And turned into decisions about where to grow. A single tree has hundreds of thousands of these command centers, and they seem to share information with each other. Once a root has chosen a path, fuzzy little drinking straws called root hairs, loaded with enzymes and transport proteins, begin soaking up water and dissolved minerals. But many essential nutrients are locked away in solid rock, so roots evolved to move into the finest cracks. Once in, they fill with water and swell like tiny hydraulic jacks, creating enough pressure to break even the hardest rock. Next, they release a mix of acid.
No way. I had no idea they could do that. That's actually really impressive. I genuinely had no idea they could do that. Oh.
That seep into the fractures and dissolve the bonds that hold nutrients in place. Claw-like.
So they actively hunt it down. They don't just passively exist. They actively pursue the things that they need. That is interesting.
Molecules grab them and pull them in before they can slip away. This sophistication really is stunning, but it gets even wilder. Even with all these tools, to really thrive, the tree needs allies. And it found them: fungi. The underground networks of fungi can stretch for kilometers. They're so small that they can go where roots can't, slipping between grains of soil to reach distant pockets of nutrients. But they need food. So hundreds of millions of years ago, roots and fungi formed a trade alliance. The trees provide a cut of the sugars they produce far up in the sky, and fungi collect and give them nutrients and water in return.
That is kind of cool. So it's a little bit like when you see stories on like National Geographic, where, you know, there'll be like a hole in the ground, and inside that hole there'll be like, I don't know, a mouse or something like that, right? That lives there. Yeah. And then the mouse is basically kind of had this kind of weird symbiotic relationship with a scorpion which will sit in the burrow with it, but more towards the entrance, and scare off anything that tries to come get into the hole. And it's almost like a weird symbiotic thing where the mouse digs the hole, which gives them both shelter, and in exchange, the scorpion acts as a guard. It's not like a conscious thing, but it's just like a relationship of convenience, if you will, like so many relationships seems to be these days. It's like, I don't really care about her, but it's convenient.
Some fungi grow directly into the root cells, building tiny trade posts where sugars and minerals change hands. Others wrap themselves around root tips, weaving between their outer layers, insulating delicate tissues and protecting them against microorganisms. Today, there are thousands of fungal tree
So it's almost like some of the funguses act as the tree's immune system, protecting it from other potential threats.
ally species, each with its own specialities. Some only partner with specific tree species, while others are happy to work with almost anyone. These connections...
So some are picky and others are quite 3 or 4. Is that the kind of the vibe we're getting here?
often knit the roots of many trees together into vast underground networks. Their scale is gigantic. In just 1 cubic meter of healthy forest floor, fine tree roots can stretch for several kilometers, and for every kilometer of root, there can be hundreds of kilometers of fungal networks. It's one of the largest and most intricate.
We're getting like creepy Last of Us vibes with this. And if you remember when they sort of lie on the ground and their head's there and all the roots going to go out, and then some poor sod like 20 miles away goes and steps on one, and then next thing you know, like the entire fucking army of the undead mushroom-faced things come chasing after them. That's why.
Living structures on Earth, and may even connect whole forests. We're only beginning to understand how complex and intricate the relationships between trees, their offspring, relatives and rivals, microbes and fungal networks are. But the more we've learned over the last few decades, the clearer one thing has become. Trees are just so incredibly wild, and we have so much more to learn.
And your mama really is so fat.